Okay guys, so this is my explanation for some of the free response questions that you guys did on Friday. Please make sure you are looking at the questions, looking at the answers, and listening to my explanation at the same time so you can understand what I'm talking about. Okay. So talking about question 1, now 1a asks you to write the net ionic equation for the reaction that occurs at the anode. Red cats make an ox happy, so I know that at the anode there is going to be oxidation. However, the question also states that there is a battery connected to this cell, which means it is electrolysis, not a galvanic cell. As a result, the opposite reaction to what I expect to happen is going to happen. So normally, if I combine iodine and potassium, I expect the iodine to be reduced and the potassium to be oxidized. But because I have a battery pushing electrons into the system, the opposite is going to occur. So as such, looking at which of those reactions is going to happen at the anode, which is going to be oxidized, I can expect for the iodide ions, I minus, to be oxidized back to I2. That's 1A. Now 1B, it says for what half reaction occurs at the cathode. Now this is quite hard. 18.7 inside of your textbook says that it is very hard generally to predict exactly what reaction is going to occur at both electrodes. Now the 1A, that question is quite simple because you've dissolved two ions inside of it and one of them is going to be oxidized. However, in terms of the reduction reaction, you have to use the other information in the question which says phenolphthalein is added and then there is evidence of a reaction. Now phenolphthalein is an indicator that changes color at around pH 8 to 10. The initial mixture is going to be neutral. As a result, it will be clear. If you see evidence of a reaction happening, that's saying that the phenolphthalein turns pink, which means that you are producing base, OH-, something that can take the H from phenolphthalein, and as a result you end up with a pink solution. So that means the reaction happening for 1B at the cathode is your bottom reaction, 2H2O plus 2E-. Okay? Now 1C, you just have to, as usual, reverse the sign of the oxidized species, which is in this case iodine, and combine that with the reaction happening at the cathode. So 0.54 becomes negative 0.54, and I combine that, add that to minus 0.83. And as a result, my answer is just going to be minus 1.37. Okay? Now then, it asks you for 3, calculate E cell for the reaction. Well, you need to use the NFE rule, minus NFE rule, and see that you've got 2 moles of electrons transferring per reaction. So as long as you got the correct answer to number 3, I believe you get the correct answer to number 4. Now on your marking, I may have not given you the error carry forward mark, but often that was because it's very hard to follow what process you went through to get your answers. So as a result, it would be hard for an actual exam reader to give you the marks. What I mean to say is that a lot of you got part 1A 3 wrong, but used it in the correct way for 1A part 4, which for the actual AP exam you might get a mark for, but only if they clearly understand what you've done. Because if you just don't show your calculations for both steps, they're just going to give you wrong for both. Okay, sorry, continuing with question 1. So B is just the formula that you see in the answer scheme. You know that 1 amp is 1 coulomb per second, and you have time that you have to convert to seconds, 15 minutes, and you can use that to work out the number of moles of electrons. The answer scheme is very clear on how to do this. Please go back through the notes if you need to review. Now C, the iodide ion is very soluble in water, however I2 has limited solubility. Say why? You just have to talk about charges and dipoles. So you would say iodide ion is charged. Iodine molecule has no charge. Water is a polar molecule. It has partial charges. Therefore, I- will be attracted. Molecular iodine, I2 will not. You have to say pretty much all of those details. You have to say I- is charged. Water is partially charged. Iodine is not charged. As a result, the negative charge on iodide ion will be attracted to the positive charged area of the water. The partially positive charge. Okay? Now, question 1D, talking about the Lewis structure for I3-. Well, first, count the valence electrons in the system, the molecule. Iodine has 7. You have 3 of them, so that is 21. then you add 1 to give you 22, the negative charge electron, so you have 22 electrons. Then draw out your molecule in the most simple form, which is I, single bond I, single bond I. Now each of those single bonds is a pair of electrons. So you've used up 4 of your 22 electrons now. You have 18 electrons left. Now first you want to try and arrange these electrons so that all of the atoms fulfill the octet rule. So what you would do is you would add 6 electrons to the iodines on the end, so 6 on one end, 6 on the other, then 4 in the middle, because that way all of the iodines satisfy the octet rule. Now, however, you have an extra 2 electrons that you don't know where they should go. Now, formal charge, which we'll get into in a later question, dictates that for substances that break the octet, let me rephrase that. Now, you do know that central atoms and central atoms which are large, like below period 3 in the periodic table, are able to break the octet rule by having an extra lone pair on itself. Okay? So it's actually best to just stick that extra lone pair of electrons onto the central I. Now, a very important idea you must have is these square brackets. These square brackets outside of your molecule, the negative charge here shown. Okay? So please make sure when you do Lewis acid structures, if you're doing an ion, you have a charged species, you surround it with square brackets and put the charge in the top corner. Okay, now for 1E. This question, although you may not have learned something explicitly about this, you should be able to infer about the size of the iodine molecule. And when I say the size, what I mean is the number of electrons. This is chemistry. Although the fact that the substance has lots of electrons is a balance of how many protons it has. It is the electrons that are affecting its chemical reactivity, its intermolecular forces, and this question about blocking X-rays. You have to write your answers in terms of the number of electrons, the size of the electron clouds, not how big the atom is in terms of its mass. Iodine is a heavier element. They're not going to accept that answer. You have to speak about it has more electrons around it. Okay, so E, organic compounds containing iodine are used as agents that block X-rays. You just have to say iodine has much more levels of electrons, quantum N shells of electrons than other elements, which makes it less likely for X-rays to pass through. Now the answer they gave was that electrons absorb the X-rays, but that's a measure of there's so many electrons that it's very likely they're going to collide with them. That would be sufficient. Okay, it would be. Now for F, bromine is a liquid at room temperature, iodine is a solid. Explain. Well, solids have stronger intermolecular forces than liquids. This means that iodine has stronger intermolecular forces than bromine. And this is because iodine has more electrons on the outside, so their London dispersal forces are stronger. And that would be it. So when you compare London dispersal forces in different atoms or molecules, talk about the number of electrons on the outside or the size of the electron clouds. They like to use the term more polarizable electrons. So you can think of it as like a giant cloud with something in the center, and when something else comes up close to it, the cloud is distorted, creating a temporary dipole, and that's what your temporary induced dipole formation is, which is your LDFs, your London dispersal forces. Okay. Now finally, the last question, the mass spec diagram for bromine is shown above. How many stable isotopes does the element have? Well, bromine is a diatomic molecule, and it seems that with a diatomic molecule, two different isotopes will lead to the possible mass spec shown below. So your smallest peak is going to be, let me rephrase that, the 2 peaks near 80 are going to represent each of your bromine isotopes, whereas the 3 peaks up at 160 indicates, well, the one which is 159, 158, whatever it is, 158, that is the combination of 2 79 bromines. Your 160 is a 79 and an 81 bromine. And then your 162 is going to be 2 81 bromines. Please make sure you're looking at the answer scheme and the question while I say these things, otherwise this is probably not going to make sense. But that's question 1. Thank you.